Hi, this is Brooks, and here's my Lab 4 report. The aim of the lab is to analyze the motion of a spring mass system in which the mass swings in an arc while also oscillating on the spring. And we gotta compare the results in tracker and in model. And here's some fundamental physics laws that we use. The first law is the Hooke's law, which is used to calculate the spring force. And we also use the Newton's second law, which is calculating the gravitational force and its related force. And the second law we use is the conservation of energy, which is called energy principle. And it is expressed as delta K plus delta UG plus delta US equals 0. And here's the results. First, I choose the option 1, which is use the video on the canvas to analyze it. And here's the video. And in the pre-lecture video, we can see the m is equal to 0.402 kilograms and the L is 0.7 meters. So we analyze the video in Tracker and we get the .csv file, which contains the x positions and y positions. So to begin with, we set the ball's mass to be the 0.402 kilograms, and the position vectors we get from the tracker data, and the velocity is 0 initially. And we can calculate the K, which is the stiffness of the spring, use the following formula, which is the period equals 2 pi times square root of m divided by K. So we have K, we have the period from the tracker data, so we can calculate the stiffness. And also about the L0, we can set up an equation which the gravity is equal to the spring force, and we know the L, we know the Ks, and we also know the gravitational force, so we can calculate the L0. And in the energy equation, we can calculate the kinetic energy, the gravitational energy, the spring potential energy, and the total energy. And in the while loop, we set up the gravitational force, spring force, and the net force, and according to that, we can calculate the ball's velocity and ball's position and its update formula. And we also can update the energy principles. And the result is that it actually follows the energy principle, which answer the question 1 on the canvas. And we can see its x position versus time in experiment is 1.65 on average, and in model is 1.66, which is very close. But in the y position, we can see that the experiment is 1.52 seconds in average, but the model is 0.1 seconds more. So why is that? So there are some explanations. First, we can see on this graph, if we taking account the reality, which is air resistance, friction, and other factors, so we can see that in y directions, there's actually more force exerted on it. So it's much more complicated and more complex than x-axis. So that's part of the reason why in experiment it's oscillating faster. And also, spring may have slight differences in stiffness along different directions, and issues with video pixel resolution, which is related with the tracker software. Thank you.